Welcome to the Explainer. You probably use JavaScript every single day, right? Well, today, we're going to peel back the layers and look under the hood to see how it really works.
I mean, think about it. What really happens when you run a line of JavaScript code? It seems so simple, you write a little code and boom, it just works. But underneath that simple surface, there's this incredible, powerful engine at work, making decisions every single millisecond. So let's pull back that curtain and see what's actually going on.
All right, so here's the game plan. We're going to build this up layer by layer. We'll start with how code even executes, then we'll dive into the mysteries of scope, master asynchronous JavaScript, tackle that tricky this keyword, and then wrap up with some really cool modern power tools.
Okay, first up, how does JavaScript actually execute code? To get started, we've got to look at the very environment where your code lives and breathes. See, every single line of JavaScript runs inside something called an execution context.
So what is an execution context? The best way to think about it is like a temporary bubble. When your script first starts up, JavaScript creates this big global bubble. And then, every single time you call a function, it creates a new, smaller bubble just for that function. Inside that bubble, it's got everything that function needs to do its job, all its local variables, you name it.
Okay, but here's a question. JavaScript can only do one thing at a time, right? It's single-threaded. So how on earth does it keep track of all the functions it needs to run? Well, that's where the call stack comes in. It's kind of like a stack of plates at a cafeteria. Last one on, first one off. When a function is called, bam, it gets pushed onto the top of the stack. It does its thing, and as soon as it's finished, it gets popped right off. The engine then moves to the next one down.
Now let's talk about a classic JavaScript quirk, something called hoisting. Before your code even runs, the engine does a quick scan and basically pulls all your variable and function declarations to the top. Now with the old var keyword, this could get messy. The variable would be hoisted and initialized as undefined, which, well, it could lead to some really weird bugs. But look at the difference with let and const. They get hoisted too, but they're not initialized. This creates what's called the temporal dead zone, a fancy way of saying you absolutely cannot access that variable before its declaration. It forces you to write better, more predictable code.
All right, so we know how the code runs. The next piece of the puzzle is where can it access stuff? Variables, functions, and that brings us right into the mysteries of scope. Here's the most important thing you need to remember about scope in JavaScript. It's lexical. That just means where you write your code in the file is what matters. It's all about position. An inner function can see all the variables of its outer function. And if it can't find a variable it needs in its own little bubble, it just looks one level up to its parent. And if it's not there, it looks to its grandparent, and so on, all the way up what we call the scope chain.
And this idea of looking up the scope chain leads directly to one of JavaScript's most powerful features, closures. I love this analogy. A closure is a function with a backpack. Seriously, it literally carries its original scope, all those variables from where it was born, around with it in that backpack. So even if you run that function somewhere else entirely, it can still reach into its backpack and pull out the variables it needs. This is amazing for things like creating private data that nothing else can touch.
Okay, let's circle back to something we said earlier. JavaScript is single-threaded. It does one thing at a time. So, what happens when you have to do something that takes a while, like fetching data from a server? How does it do that without just freezing the entire page? It seems impossible, right?
Well, the secret sauce is the event loop. This is the absolute core of how JavaScript handles asynchronous stuff. The best way to picture it is like a really smart restaurant manager. The call stack is your chef, who can only cook one dish at a time. When a long order comes in, like a network request, the manager doesn't make the chef just stand there and wait. No way! The manager takes the order, hands it off to the browser's kitchen staff, and lets the chef keep cooking other things. When the long order is finally ready, the manager puts the finished dish, your callback function, in a queue, waiting for the chef to be free. It's brilliant, and it's why your web page doesn't just lock up.
And it gets even cooler. Our restaurant manager is so organized, they actually have two separate waiting lists, or queues. There's the high priority list, called the microtask queue. This is for super urgent things, like when a promise resolves. The manager will always clear out this entire high priority list before they even think about looking at the other one. The second list is the regular macrotask queue for less urgent stuff like set timeout. This whole system makes sure that the most important updates happen right away.
So we just mentioned promises. What are they? Well, a promise is literally what it sounds like. It's an object that represents a future value. It's a placeholder, a promise from JavaScript that says, hey, I'm working on this, and I promise I'll get you a value back, eventually. It starts out as pending, and then at some point it will either be fulfilled with the data you wanted or rejected with an error if something went wrong.
And why should you care so much about promises? Because they are the bedrock for the modern async await syntax you see everywhere. Async await is just a much cleaner way to handle promises. It lets you write asynchronous code that looks and reads almost exactly like normal synchronous code. It saves you from the nightmare of nested callbacks, what we used to call callback hell, and makes everything way easier to read and debug. All right, let's shift gears a bit. We're going to move into JavaScript's object model and tackle the this keyword. Yeah, probably one of the most misunderstood and confusing parts of the entire language. See, a lot of other languages use rigid classes to create objects. JavaScript is different. It's more flexible. It uses something called prototypical inheritance. Here's the deal. Every object has a hidden link to another object, which is its prototype. So when you try to access a property on an object and it's not there, JavaScript doesn't just give up. It goes and checks that object's prototype. Not there, it checks the prototype's prototype. It just keeps walking up this prototype chain, kind of like a family tree, until it either finds the property or runs out of ancestors.
Okay, let's demystify this. The absolute #1 thing to remember is that the value of this has nothing to do with where the function is written. It has everything to do with how the function is called. And there are really just 4 main rules you need to know. If you just call a function normally, this is the global window object. If you call it as a method on an object, like myObject.myMethod, then this is that object. You can also force this to be whatever you want using tools like .calling. And then you have arrow functions. They're special. They don't get their own this at all. They just borrow it from their parent.
So about those tools for explicit control, you've got 3 main ones. .call and .apply are pretty similar. They both run the function for you right now and let you specify what this should be. The only difference is how they take arguments. But .bind is the odd one out. It doesn't run the function at all. Instead, it returns a new function that has its this value locked in permanently. Super useful.
All right, let's bring it home. For our final section, we're going to take a quick look at a few modern JavaScript power tools that make our lives as developers so much easier.
Have you ever heard of a symbol? It's a pretty neat data type. The best way to think of it is as a 100% unique secret key for an object property. Every single symbol you create is guaranteed to be different from any other. So what's that good for? Well, it means you can add a new property to an object without ever having to worry that your property name will accidentally clash with some other property that's already there.
Okay, these two are lifesavers. They solve such common headaches. First up, the nullish coalescing operator. That's the double question mark. It lets you provide a default value for something, but, and this is key, only if the original value is null or undefined. It's way more precise than the old trick of using the OR operator. Then there's optional chaining, the question mark with the dot. This thing is amazing. It lets you safely try to access a property deep inside a nested object. If any part of the chain doesn't exist, instead of crashing your whole program, it just gracefully stops and gives you back undefined. No more cannot read property of undefined errors.
And then we have generators. Now these are kind of mind-bending but really powerful. A generator is a special kind of function that you can pause and then resume later. You use the yield keyword to pause it and send a value out. Then, later on, you can pick it up right where you left off. This lets you do some really advanced stuff, like creating your own custom iterators for complex data, or managing really tricky async flows step by step.
So from the call stack all the way to generators, what we've really built here is a mental model of the entire JavaScript system. And the most important takeaway is that none of these things are isolated ideas. The call stack, scope, the event loop, prototypes, they are all interconnected gears in one big logical engine. And that's the key. Understanding how the whole system works together, that's what takes you from just writing JavaScript to truly mastering it.
So, you've now seen the secrets of the engine. How is this going to change the way you write code? Because once you understand the why behind the syntax, you're not just writing code that happens to work anymore. You can start writing code that's efficient, powerful, and bug-free on purpose. You now have the mental model to know what your code is really doing. Thanks for watching.